Alright, what I want to discuss here first up, we're just entering the section on forces, and so I think we should have a little Newton's laws. Now the first one stated that an object in motion stays in motion. What does that mean? It means if you've got an object here doing 20,000 meters per second, which is very fast, then it will do that forever unless there is a force opposing it. Counterintuitive, because nearly all our objects on Earth are affected by friction and drag and slow down. I couldn't believe it. I couldn't believe that an object would just go forever. I don't know how he came up with that, but he was right. Second law, F equals ma. This one says that if you exert a force on an object, then the acceleration is going to be proportional to the force. Bigger force, bigger acceleration. And it's just multiplied by a constant, mass. Therefore, they're directly proportional. Bigger force, bigger acceleration. What's inversely proportional is the acceleration and the mass. Bigger mass, smaller acceleration. Alright? So that is Newton's second law, and it's the one we're used to using. Newton's third law is all about equal and opposite forces. Newton's law says that for every force there's an equal and opposite force. Now this is the one you can easily make a mistake with. What it means is this. Okay, so I'll just move this up a tad so that if we need that extra bit, we've got it. Is that it's, well, I'll tell you what it doesn't mean for a start. If you've got a box sitting on the ground and we know it's got a weight force, then you guys probably already know that it's got a support force, both acting on the center of mass of this box. But that's not the pair of forces that Newton is talking about. Okay, those forces are acting on the same object. Okay, they are not the pair that Newton is talking about. He's talking about an equal and opposite force, and they act on different objects. That's the key to help you figure out what he's talking about. So let's have a look at a few examples. If this is the Earth and an object, maybe me, dropped out of a plane, is falling, then I have a weight force. It's gravity acting on me, and it's equal to mass times the gravity. So I've got a force acting on me. Where's Newton's equal and opposite force? Well, it can't be acting on me. It must be acting on the planet. That's the equal and opposite. How's it equal? Same size. How's it opposite? Opposite direction. So you might say that the Earth attracts me and I accelerate towards it. But you can also say that I attract the Earth and it accelerates towards me. But F equals ma. The bigger the mass, the smaller the acceleration for the same size force. And these forces are the same size. So the acceleration of the Earth towards me as I drop out of a plane is very, very, very small because the mass is very, very big. But the actual force acting on me is the same as the force that acts on the Earth. Another example might be, got a rifle, and you shoot a bullet out of it, right? When that bullet has a force exerted on it, in here, right, then there's an equal and opposite force exerted on the gun. So we have a force, that's what makes that little guy accelerate. Maybe it's a force that looks like that. That means there must be a much bigger force acting on the gun. Because this little mass is little, it's going to accelerate much more than the gun. So that's the recoil you feel. Acting on different objects. Remember that.